Hey, hey, PVA! Coming at you not live from my backyard. I'm Miss Coffee. That's Copper and Miko and Sadie that are going to bark probably during this video. Let's get started. Okay? That was fun. All right. So we are now starting a new unit. Done with surface area and volume. We are doing probability. What's the probability that you're going to understand this lesson? I don't actually know that. Okay, but I can figure out the probability of lots of other things. So make sure you have your notes ready to go. Here they are, posted on Google Classroom, also on OneNote, or you can just copy this down. You can print it out. Do what you need to do, people. All right? Okay, let's do this. Oh, but before we begin, you know what we gotta do? Ready? Channel the math energy of the universe all across Houston. Yay, math! Yay, math! Good job. Here, Miko wants to say hi. Say hi, Miko. Miko. Okay. So, today we are talking about experimental versus theoretical probability. Cool. Here's how I like to describe that. Oh, well, first we should actually talk about the meaning of probability, which I hope you know. That is the likelihood something will happen. Right? Like, what are the chances you're going to understand this? Who knows? Move that over. The probability ranges from 0 to 1, but it can also be written as a percentage, which is the most common form that you'll see probability written as, right? So you might say there's an 80% chance you're going to understand this lesson, but it doesn't have to be a percentage. It can be written as a fraction, okay? So, for example, there's a 3/4 chance that it's not going to rain today. I don't know. That would be a 75% chance. Or you could have an integer, but it has to be from 0 to 1. So if I said the probability of something happening is 1, then that means it is 100% going to happen. Okay? If I say the probability of something happening is 0.8, that's equivalent to 80%. All right? So there's many different ways that you can write out the probability. On your homework, it's going to ask you for various ways. It's either going to do a percentage, a decimal, or a fraction. So you just have to read the instructions to know how to answer that. Okay? Okay, so let's talk about theoretical versus experimental. This is just a general summary, not the formal definition. Theoretical probability is what we expect to happen. Okay? Experimental is what actually happens. So, you know, like all those memes that you see? I did a thing. You want to see it? I'll show you. Look at this. Let me make it nice and big here. Okay. It says, sorry, the words are whatever. Okay. It says, what I think I look like on Zoom, what I actually look like. That is courtesy of Copper, Lopper, Bopper, who is very cute and psycho. All right, so we're just going to minimize that. Keep that right there for you. Okay, so that's basically what theoretical and experimental is. What do we think is going to happen based on numbers? What actually happens based on an experiment or based on something that is actually happening instead of something theoretically happening. So these are the formulas that we're going to apply, but this is kind of common sense-ish, but if you need to reference these formulas, they're there for you. The probability of, this is the notation here, okay? So this is how we notate the probability of an event. So this E right here stands for event. Probability that something will happen. You take the number of favorable outcomes divided by the number of possible outcomes. Okay, so if I am trying to roll a dice in a board game, and I'm gonna win the game if I roll an even number, you would count the number of even numbers on the dice, which would be 3. because you have 6 total, the number of possible outcomes would be 6. So the probability of you rolling an even number would be 1/2. 3 out of 6, 1/2. In an experimental probability, you take the number of times an event actually occurs and you divide by how many times that experiment is done. So the example here with die would be, let's say you roll a die 100 times. So that means the number of times you're doing this experiment is 100. Out of the 100 times you're actually rolling the die, it's going to take a long time, you count, you like tally up how many times I get an even number. So let's say you did that and you got an even number 60 times. So your probability of rolling an even number in this experiment is actually 60%. Because we know, even though the theoretical probability was 50%, 1/2, right? 1/2. We know that actually in real life, that doesn't always happen. It's like the weather. They're going to say there's a 50% chance that it's going to rain today, right? But then it ends up definitely 100% raining. Or they could even say, you know, there's a 10% chance that it rains. Okay, so most likely it's not going to rain, but experimentally it could rain. Okay, let's look at some examples. By the way, these I adapted directly from the homework, so they're going to be really similar. So my suggestion would be, you can take these notes and then do the homework, but you can also have Pearson pulled up while you're listening and taking notes. That way you can kind of pause the video, pause your note taking, and actually complete the Pearson homework right after you do this example. So this is directly from the first example on your homework. So let's try that out. It says, out of 50 students surveyed at a school, 14 of them ride the bus. Okay. First of all, we're going to calculate the experimental probability that a randomly selected student at this school rides the bus. So, okay, so here's what you want to figure out. You want to think, okay, experimental probability is not the theoretical. It's based on the experiment above. So this experiment is what I'm using, right? So if the formula for experimental probability is how many times does an event occur divided by the number of times the experiment is done, it's a little different in a survey, that's going to be this 14 number divided by the number of students that you surveyed. That's like the number of times you do the experiment. So the probability that someone rides the bus, so here's how I'm going to notate that, is going to be, and again, this is the experimental probability, is going to be 14 divided by 50. That's it. That's all you got to do. However, you want to make sure that it is simplified. If it asks you to simplify the fraction, so on your calculator, you can divide that, but then convert it to a fraction. So this is going to simplify to 7 out of 25 as a fraction. If the question is asking you for a decimal, then you want to say, okay, divide that on your calculator, and it is 0.28. If it wants it as a percentage, which sometimes it does, but not all the time, that would be 28%. Okay? Those are all correct. Those are all the same exact number, just in a different format. Okay? Okay. So that was the experimental. Now we're going to look at the theoretical. Okay? So that's going to be this right here. It says, predict about how many total students ride the bus if the school has 800. Oh, no, I'm sorry. Beep. That is not going to be the theoretical. Sorry, we'll do a theoretical example in a moment. This is just predicting based on the experiment how many students approximately would ride it if there were 800. Okay? So that means we want to take essentially this 28% or 0.28, and we want to multiply it by the total number of students. So based on the survey, we think that there's going to be about 224 students that ride the bus. Now, is that accurate? No, not necessarily. Because I did an experiment, this survey, where I only tested 50 students out of the whole school. It could be a totally different number based on the population that you sample. So this is used a lot in real life when you're sampling sizes, when you're getting statistics, when you're doing surveys. And that's why it's really important to have a very random survey or group of people that you're interviewing, essentially. It's very important to have random instead of going only to, maybe you only surveyed people that were outside coming in right off the bus ramp. Well, most of those people are going to be riding the bus. So you need to make sure when you're doing surveys that it's completely random. Okay. Let's look at this other example. Looks like this one is also going to be another experimental one. We'll get to the theoretical in a second. Okay, so experimental. It says from 5,000 laptops provided by HISD, an inspector selects a random sample of 150, laptops, and finds 10 of them defective. Estimate the total number of defective laptops. So what that means is first we have to do part A and then we'll do part B. So part A is the experimental probability. The probability of, in this survey, where there were 150 laptops sampled, I found only 10 of them to be defective. So that would be 1 out of 15 as a fraction, which is going to be 0.6. That'll be approximately 7, which is approximately 67%. I'm going to use this, though. I'm not quite done, though. That's not my final answer, because it wants me to then take that percentage or that fraction and determine, or not really determine, but estimate the total number of defective laptops out of the 5,000. So then I'm going to take that, I'm going to use this fraction, 1/15, and I'm going to just multiply it by 5,000. So multiply that, and we get approximately 333.3. So they'll probably ask you to round to the nearest whole number, because you can't have a third of a laptop. So they'll either say that's 333 or 334. But that is how many approximate laptops might be defective just based on our sample size. Okay? All right. So that's a summary of experimental. The next video is going to cover theoretical probability. Cool? Okay, so I'm going to pause here. Go to the next video. Peace out.